Okay, hello everyone and welcome to Handmade Heroes, show where we code a complete game live on stream. In this particular case, I will say that we're on a little bit of a diversion, and it's a diversion that I decided to take just because, like I said before on the stream, we won't really get a chance to talk very much about UI code in Handmade Hero because it's not a game. It's not a 4X game. It's not Civilization or something where there's a lot of UI. It's not The Sims, where there's lots of like pop-up menus and radial menus and crazy stuff like that. And so I just thought I would do a quick detour to sort of talk about those sorts of things and give us maybe a little bit more debug UI than we would otherwise have. Like if we were just sitting here going, what's the absolute minimal thing we could get away with for a debug display? It might be something very janky with only like minimal keyboard controls, or maybe we would just implement just a console and there's no overlays and no mouse interaction at all. It's just like you can type some text and get some printouts or something. But I thought it would be a little more interesting if we actually kind of went into detail and had sort of more of a discussion about how user interface code is implemented. And again, this is not meant to be a full explanation of that, because implementing user interface, a full user interface library, is a big topic and warrants plenty of time on stream to it. That would be something that we'd spend 100 days on if we wanted to do here is the complete UI library meant to ship applications on and all this other good stuff. So I'm by no means trying to say that we're going to cover it completely, but I just wanted to do some things where we kind of show what's going on. And so I'm going to do some programming today to day 200. So you want to unpack day 199's source code. And I'm just going to continue down a little bit this sort of path of pulling things out, cleaning things up, so you can kind of see how to make a little bit of reasonable UI code. Again, if this is something that you are interested in doing for your code yourself, when you are making your engines or your games or whatever you're making, if you want to add some UI to it, or you want to add debug UI to it as well, again, that's just kind of what we're working at here. And so you can remember kind of what we did is we started to talk about these interactions, and we sort of pulled out the code that does these interactions into something that was a little cleaner and can now be used a little more generically. So we have stuff like, if you open the profile, it's got like a resize interaction here, and we didn't have to rewrite that interaction for here. We could just use the same one. And furthermore, we could even constrain the aspect ratio by just adding 1 or 2 lines of code in the thing that actually draws these guys. And so again, what we're kind of doing here, right, is we're focusing on how we can architect this code for its desired purpose, which is really flexible, quick ability to add new UI things so that as we want them, we can just add them and we don't have to worry too much. It's not like a big overhead to the programmer to put in new widgets or new tools or stuff like that. So that's really what the focus is, kind of the way that we're architecting this as we go. And that's a pretty good way to go with a debug UI, right? Because especially with a debug UI, you really don't want to be spending all of your time later on in the game when you're trying to do something else, i.e. not working on the debug code. You want to do the debug UI code and you want to have it done. And then later on, if you want to add something, you don't want to be in this situation where it's going to be this huge investment of time to go re-architect the code and pull it apart to add this new widget or whatever you need to do. You want to be able to just really simply go in and change a few quick things, leverage existing code really easily, and have the new widget that you wanted or whatever, right? And so that's kind of more like what I said, what we're talking about here. Okay, and so what I wanted to look at today, since we kind of abstracted that widget code, the interaction code reasonably well yesterday, there's more we could do, but I think, like I said, this is not meant to be an entire, massive section on UI or anything. What I would like to do now is take a look at the actual way that we're doing the drawing of the debug UI, right? And there's really 2 things we can do with this. I don't know, we can start with that today, or I can push it off to tomorrow. I'm trying to think of exactly how I want to do it, because the other thing that we could do is do the deep copying of values, because the other thing that I was saying is, we had this thing where when you copy something, like if I copy the renderer over here and I make another copy of it, it does this kind of weird thing that you can see where it it has kind of, because it's just a referential copy, it puts everything exactly as you see it, and everything is mirrored completely. And we don't really want that, right? And we also want the iteration to kind of be locked to just inside its children. And there's just a bunch of things that we are currently living with, but that I don't think we would want. And so I don't know how relevant that is to the drawing part of things. So I don't know. I think I may stick with just let's go ahead and make the drawing stuff work properly and go from there. Okay. So let's just take a look at that, and we'll see what we can do from there. All right. So what I want to do here is I want to take a look at how we are currently drawing things, and I just want to start pulling it apart in a way that it's not quite so ad hoc, right? Because if you look at how we are drawing them now, I did, and again, this is what I think you should do. This is not like, oh, we were bad people for doing this way. It's just you don't want to leave it this way. What I did was I said, like, okay, inside debug draw menu, here is a for I loop. And what I will do in this for I loop is I will go through, and for everything that I have that's a type that I want to draw, I will just go ahead and put the code in here that draws it. And that's exactly what we did with the interactions the first time too, but then we went through and said, okay, let's make a little type called debug interaction that can sort of capture what those things are that we want to do, so that then we could start leveraging actual calls to these things to make it so that they are no longer totally ad hoc, that we could do things like interaction is hot, test to see if a particular interaction is hot so we can highlight things properly, and then we can just assign the whole interaction to something to make that the hot interaction like we do here. And it just kind of makes it, again, it starts cleaning up that code and making that code a little bit more reasonable. So what I'd like to do is that same exact thing with the drawing code. And you can see here that I've got the drawing code is just very, very ad hoc, right? I just kind of create things like I'm computing minimum corners, maximum corners. I'm doing like these sort of, I'm putting widgets in the corners of these things and computing where that is myself. And so what I'd like to do is maybe pull that code out as well, so that we can start to think a little bit more directly about that, right? So we can start to have shared code where we're having sort of like duplicated code. And that way we can sort of make those things a little richer, make those things potentially a little more interesting or a little more robust by focusing on just having it in one place. And so we can make sure that place does things well. So all I'm going to do here is start by just, again, doing the standard kind of compression-oriented programming sort of thing. I'm going to basically try to just put out here some things, like I'm just going to try to like loft up some of these things that we're doing into a function. And I'm just going to see what comes out of it, right? So if I look at these two things here, like in particular, like the bitmap display and the counter thread list, right? We can kind of see, and you know what, even let's take a look at this guy here as well, right? We can see that a lot of these guys, they sort of have this notion of starting at a particular place, and that place is almost always the same, right? And in fact, we kind of have a situation, if you want to look at it, where we've really just kind of duplicated totally willy-nilly some very specific things that are happening here. If we wanted to change like how the indentation works in these things, we'd have to change it in all three places, right? So you can really see how that code is kind of getting duplicated out there, right? So I think the first thing I'd like to do is pull that out into something that can be common, right? So I'm just going to go ahead and start here by saying that, okay, maybe we've got some of these things like the depth, and the line advance. Maybe I'll just go ahead and pull those out here, so that when we're actually working on these separately, and maybe this at y and at, these look kind of like good candidates too, right? Maybe like this. And I could even, if I want to, just make that be an at, right? So you can kind of see that these things are being used. So I'm just grabbing them out and putting them here. And so then if I wanted to, I could say that this was, something like a layout or something like that, right? And I'll take the layout, and I'll say that when I initialize that, I'm going to take all of these things that I was doing originally into variables. And I'm just going to bundle them into this structure. So nothing has changed. Everything is exactly the way that it originally was. But now these are in the structure, and the reason that I'm putting them in the structure is not because I just want them in a structure. It's because now it's trivial for me to pass that whole state over to another function. And so essentially what we're doing here basically is we're sort of making our own little version of, like almost our own little closure. We're basically saying we want to have some layout routines. These layout routines are going to have to know about this stuff. And since it's pretty hard for me to say like in C that they're like local functions or something, what I can do instead is just bundle up the actual local variables into a struct and have that struct be something that I can then pass as like the first parameter to these layout routines so that they will be able to do the things that they need to do, you know? All right, so if that is what, if that's taken care of, then you can start to see how, like in here, maybe some of these things can start to be automated, right? And so right now we have a sort of an annoying thing where we do this at y get min corner thing that happens, right? It's kind of the reason that we did it that way, and with the bounds being the way they are, kind of like being processed in here. Like almost all of that stuff is just because we were trying to share the advancement code. We were trying to make sure that the advancement code was the same. So the bounds would like flow out, but there's no reason for these bounds to even ever flow out of these case statements. There's nothing that even says that there's not multiple bounds per object potentially, but we just were kind of trying to leverage that sort of single code path in terms of advancement. So now when we think about it, we've got like opportunities now to make that not be a thing. So what I'd like to do instead is start to look at that in a more holistic way, right? I'm going to pull the bounds inside for now, right? I'm going to have it be something like this. So I've got these bounds everywhere they're in here are going to be local functions. Here we go. And you even remember it was kind of finicky to do the text thing because of the way we were doing it, because we had to like make it come out with the bounds and all these other things. So, we actually were kind of bending over backwards to support that as well. So here we are with our, oops, that was not my intention. Let's get back there. And you can see then we get down to here and we're going to use the bounds to advance by y. And what I would rather do, like I said before, is I would rather have something where these guys themselves do a little bit more of that work, right? They do a little bit more of that advancement. So maybe, we'll just start with something like, let's say we call advance on the layout, something like this. Now that's not exactly what I want yet, but that's roughly what I want it to be. And I want it to be, something like this, right? So I'm just going to go ahead and put that in here temporarily. Again, this is just kind of like a very simple sort of a thing. And I think also we can go ahead now and just do exactly what it was doing, which is to get that min, sort of that minimum out of there. So if I go ahead and say, okay, there's an advanced function. This advanced function takes the layout. There's the layout, and here is the bounds. Oops. Then what I want to do is take that bounds. Oops. Want to get the minimum of that, get the minimum corner. And then I'm going to take that y. And we're just going to make the layouts at y equal to that get min corner. That's all we were doing before, and that's all we're going to do now, right? So now if I come through here and kind of port this stuff, you can see that now I no longer have to do this assignment component-wise, because we're actually just going to take it directly, so that's nice as well. And so let's go through here and now port like all the rest of the compile errors that we're going to have for having switched this up a bit. So here we've got layout.addx, right? We've got layout, oops, at.y, so that's good. Let's keep going through here. We've got another one here, like so. We've got the bounds min, the spacing y is now in there as well. Let's see what else we've got. Let's see here. Oops, that's not a pointer. Not a pointer. Really not a pointer. There we go. Okay, the depth is also part of the layout as well. The line advance, also part of the layout. What else we got? Keep on going. We have, again, the line advance. We've got the depth. And we have, let's see, here we go. And not much more here. So, there we go. Layout spacing x, spacing y, at x. There we go. And depth. Line advance. Line advance. Nothing particularly interesting. Nothing to see here. Just the basic porting. And I think that's about it. So now, in theory, we should be back to the point where everything is, yeah, you know what? This is a little bit weird because I guess we never really specified which one of these guys it was going to be. So that's a bit strange. We'll probably have to talk about that in a second, but that's fine. We can fix that as well. Let's see here. Because that looks like, is that actually, well, I guess I don't have to move it in there. There we go. All right. So this should all be the same as it was, and it does look that way, right? So that all seems pretty reasonable. Okay. So now what I'm going to do, now that I have this layout structure and everyone's using it, I'm just going to go in here and start to pull out things that are obviously like very, sort of duplicated, right? Things that that look like there's just no really real reason for them to have to be done custom. They could be shared, right? So in this case, like when we look at the counter thread list, you can kind of see that like the dimension is something that's rote specified. Like we just have the concept of a dimension for this thing. And so there really doesn't need to be any particular reason for us to do this computation here. This could be something that anybody with a dimension could use, right? So we could do something like, all right, instead of having like advance or whatever, this sort of thing, we could just have something where if you want, you can get a rectangle 2 back where you could just say like, I don't know if it's what would the right thing here, like insert or place, just maybe like place rectangle or something like that. And all you would do is you'd say like, okay, what's the dimension of this thing? So I would say something like, here's the dimension of the thing that I want to place, and then you'll just return to me the rectangle in which I should draw that thing. You know what I'm saying? Something like that. And so we'll start, and again, we want to do something, we want to do a little bit more than that, but again, we'll just start there again because it's a simple thing that you can see. I can see it in the code, and it should be pretty trivial. So if we hoist that out, you can see we have min corner and max corner here, and we're creating them this way, right? And then we end up making this sort of rectangle bounds thing out of it, right? So in order to do that, you can see that all of this stuff is stuff that I know about on the layout, right? I know the layout, various at things and all this sort of thing, right? I know all of that. And so now all I really need to do is just make sure that I'm only using the dimension stuff that gets passed in here, like so. But everything else is the same. And so what you can see here is this is all calculated for me automatically. That's all good. We then can make the rectangle min max, and we can return that. And that's all we would have to do the place rectangle. Now we can basically replace this code right here by saying, all right, I want to make my rectangle 2 of the bounds. I don't know what size p. Oh, that's the location where we're going to do that. So size p is really just the max corner, min corner of this thing. So I guess we would just do like get max corner of the bounds, get min corner of the bounds. That's really just that. That's the size p. So now we can kind of say like, all right, all of this stuff does not matter. We'll just grab the dimension, pass the layout, and then all of this stuff just kind of nicely goes away. Right? And all of this stuff just kind of works. So in theory now, our profile stuff is going through there and should just work. And it does. So that's nice. So that's step 1. And now step 2 would be, it would be nice if we could do the same thing, just leverage that same code. And you can see here how we have sort of this bitmap scale notion. And what we did is we sort of corrected the bitmap scale notion by using this, right? We sort of corrected that bitmap display dimx, that stuff. But then once we did that work, and you can see here actually that min corner, like we were passing it here, but we don't care where it actually was because we were just getting the dimensions. So really this could have just been complete nonsense. And min corner could have just been moved down here, right? There's nothing, because all we need to know was the size of the bitmap. We didn't really care where it was, right? So what we can do now is say like, all right, after doing just this little preamble and correcting the size, which we want to do, we can now leverage this code that we pulled out into the layout routine to have it do the layout for us, which is what we want, because now, again, we're reducing that code duplication and making it so that things are kind of nicely coherent, right? And now what you can see is it's going to get that size p, which we can copy from here. Hopefully you are getting the same sense that I am about that size p. If you're not, that's okay. We'll talk about it in a second. But anyway, yeah, you can then see, like, okay, this guy needs to get the min corner of the bounds in order to draw the bitmap there. But then, again, we've successfully compressed that code, which is great. So now this and this are using the same layout routine, and that's exactly what we wanted. Because now, again, anyone who wants that sort of thing can just make that happen, right? Can just make that sort of bounds thing happen really easily for them, and they don't really have to do any more work on it, right? Okay. So what I'd like to do now is I'd like to expand potentially this notion, because when we were doing that, like I saw, like I kind of just pointed out, the size box is also the same on both of them. So it would be kind of nice if the layout routines could just do the size box for us. Because again, then every time if we wanted to go add something that worked the same way that these profile or the bitmap views work, if we wanted to add those, we could just leverage that code, right? We could make it so that anyone who wants a size box, it's free. They just say, like, oh, by the way, I want a size box, right? And that's what you want in a good UI system. You want it to be really easy for people to just say, oh, I wanted to use that thing. And it's as easy as possible for them to do so. So how do we do that part, right? So to do that part, what we'd like to do is pull out these things. You can see there's the size p, right? And let's see where that drawing happens, right? So you can see it all happening here. We've kind of got this part occurring there, like that. And so if you look at it, we've got some things that are pretty tricky here, right? So first of all, we know that the size p is related off the bound, so that's pretty easy for the layout system to understand. It's pretty easy for it to know how to draw like whatever it wants to draw, like whatever it's trying to draw, like that little square. That's not a big deal. The size interaction is pretty obvious what it's going to be, but you could always override it as well, so that's not a big deal. But this part is a little trickier. It needs to be able to override whatever is happening in this, because we want to make sure that these rectangle calls don't sort of conflict with each other, right? If I was to do this, then we'd have sort of a bit of a problem on our hands, right? Because if you look at what occurs when you do that, you can kind of see that now the upper part, well, maybe you can't see that, actually. Maybe only I can see that because it's like not going to be clear enough on the Twitch. But, well, actually, you know what I can do for you? Here's what I'll do. If I just make this much bigger, and obviously this is ludicrous and you wouldn't want to do it, but it just makes it clearer. So if I come in here and open this guy up again, now I've got a giant size box. Well, you can see that only part of the rectangle works. This part works just fine, and I can grab it, but in here it doesn't work. In here, it thinks I was interacting with the circle, with the bitmap itself, and it does the tear-off interaction, which is what we want it to do, but not when we're right there. When we're right there, I should be interacting with this. That is because, like, the way that we are doing our hit testing right now is just in order, which means that whoever hit tests first is the weakest, and whoever hit tests last is the strongest in terms of who gets preference, because it just overwrites whatever the earlier hit tests were, right? Now we could introduce a z-value or something here if we wanted to sort of sort those, but it might be, I don't know if we really want to do something like that. Is that really necessary, and so on. When we could perhaps just make sure we architect this thing to tell us essentially whether or not we're interacting with what's in that, or whether we're inside that particular thing. So what I was thinking is, we could do something more along the lines, I'm just spitballing here. What if we did something that was more like this, where we said, excuse me. What if we did something like, okay, we want to do a rectangle. So we do something like begin rectangle, like this. So this is like a, oops. This is a layout, or layout element, we'll just say, right? And this is going to be our only element, really, that we have. So we'd say something like, begin element rectangle, and we pass the dimensions of that rectangle. Then we would say, something like add size, or make sizable, or element set sizable, make element sizable. I don't know the name. I don't. I'm not just saying that. I literally just don't know the name. So like I want to make this element sizable, whatever it is. So let's go ahead and do that. And then at the end, you just do something like if and element, like that. And we'll just say that this will return to you, whether or not you should process your interaction, whether or not you're like the mouse is going to be something that you're going to deal with, or whether it's something that was dealt with by the layout system, right? So it just kind of lets you know. And that way we wouldn't have to introduce things like Z or stuff like that, which may just overcomplicate things for no real, obvious value, if that makes sense. Seems pretty reasonable. And so if we do something like that, then we would end up being able to abstract presumably all of this stuff away, right? Like all of this stuff could kind of get sucked up into this system here. That was a little typo there. And so this would start to look pretty nice at that point, right? We would sort of have this ability to do the layout like this. And, this is just a regular drawing code that we're using to draw everything. We wouldn't need to draw the size box. That could be handled up here as well. So yeah, I think that's pretty good. I might say that like maybe we draw this first so that we have the UI system can draw like on top of us. But otherwise, you can see this is starting to get like much nicer now and doesn't have all of this stuff in it. And this guy would get even simpler, right? Because this guy doesn't need the size interaction or any of these things or the size box. He just has his draw profile in call, right? And so he would be even simpler. He would just look like this, where we do like element, make sizable end element, something like that. And then in here, it would just look like this, right? So I think that's pretty good. So all we would really need there is a way of saying what the dimensions actually were that we wanted sized. Now there's a couple of ways we could do that. I'm going to go for the most direct route here. I don't know if it's the best idea, but I'm going to do it. So when we pass the dimensions, I'm going to pass the address. And then it will just know when it's sizable, it will use the address that was already passed in this function, right? So now you can see we're getting like really pretty simple here for the most part. And yeah. Well, you know what? Now that I think about it, there is one thing that's a little bit trickier here, right? Which is that we don't know what the bounds are perhaps until the element is finished. So that might make it a little harder in that sense. I'm not sure how I feel about that. Well, let's find out. I'm going to go a little further with this because I can't quite predict what I want. So I'm just going to see how it goes by playing around with it. So what I'm going to assume is we have something like this, where we just do draw profile in at the end, element.bounds, like this, right? And that's, I guess, just what I'll do for now. And we have make elements sizable there, so this all kind of works out. And we have something that looks like this. Now, at that point, advance is no longer really necessary either, because advance can happen inside here, inside where we do our element stuff. So we can also kind of just say that the advancement happens like in here, right? And so I think we're now down to like some really straightforward stuff. So you can kind of see we've got all of this stuff compressed pretty tightly. There's not very much code that you would have to write. And in fact, this part right here, we could almost also do, we could almost let that happen automatically as well. We could say something like the default interaction gets passed in here, like something like default interaction. You know what I'm saying? And then it would just look like that, right? And that's pretty good too. So maybe we'll do it that way as well. That's pretty good, I feel like. So we just say, okay, we have a tear interaction here that we're going to do, and then we would say, you know, this sort of thing. Default interaction is the tear interaction, and there's that element again, right? The bounds min x min y thing minus equals layout spacing y, that should also probably be in here, and we should probably just have a way of turning it off, I'm guessing. So it's probably something like, oh, okay, you know, we're going to add the spacing right here, right? And then we just do something where that would be turned off. So we do something like, you know, if there was some kind of override for the text. So I think that looks pretty good to me. That seems like the right thing. Again, this guy's code is a little more complicated just because he's doing more unique stuff, right? But it seems pretty good. Again, it's simplifying quite a bit. And so then here, I think we have roughly the same thing happening. We're getting the text size. That can happen at any time. And then we're sort of doing a bunch of fussing here with these things. Here is obviously our height. Like, we know what the height is. And our width is just going to be, excuse me, our width is just going to be the text bounds width. So I feel like, you know, we could probably duplicate this pretty easily by just doing like, you know, let's see here, do this exact same code. If we were going to phrase it in this exact way, right, we would just do something like, okay, begin an element, the v2 for this guy, this is the dimensions, right? The v2 for this guy is going to be the text bounds, get width text bounds, and then whatever the layout line advance is, right? Something like this. And so this stuff can kind of go away, I think. The debug text out, that's going to be whatever the bounds come back as, right? And now I can also, this item interaction is the default interaction as well. So all that stuff goes away, right? And so looking at this stuff, well, I've got left px, that's just going to be the get min corner, right? That's just going to be whatever my element bounds are after it's finished. And then the top, where we do the get starting baseline thing, I believe that's just going to be, so get the max corner y. And then we're doing this sort of like offset to align the font properly, to align where that's going to be baseline wise. But then this goes away as well, you know? So I think that's relatively clean again. Like, seems all pretty straightforward. I like the look of it. It's pretty reasonable. And now all of these guys are going through the same path. So let's go ahead and see what it looks like if we just implement those exactly as they are. All right. So what would I do there? I would go ahead and say we have these functions. And I think those are actually the only functions that we have, right? So we have like a function here that returns a layout element. It's called begin element rectangle, right? And it takes a layout, and it takes a pointer to the dimensions of that rectangle. We then have a layout element here where we say that we want it to be sizable, and that would add the size box to it. We then have a way of setting its default interaction, and that is just going to be a debug interaction. And finally, we have a way of ending it. saying that we were done with all of the specification that we wanted to have. So I think that's all good. The way that this is working now, we can kind of just do this all in line at the moment. So I feel like that's probably good enough. So I'm just going to go ahead and do it all inline. You could defer this stuff to the end so that when you call end element, you do it. Trying to think if that makes sense. It probably does. Let's go ahead and say that it does. So here is like v2 dim there. This will be the size pointer as well there. We'll have the layout itself in here. Just putting these together here. This probably wants to be in there as well. And all this is really doing is naming a bunch of stuff and storing it around so that it can be done in sort of that piecemeal fashion, so that people can kind of construct the UI element they want and get it, right? So yeah, I think that's all good. I feel like that all makes relatively good sense. So let's just go ahead and implement that. When I do begin element rectangle, what I'm going to do here, oh, and then of course we have some out params. Which was like the rectangle 2, which are the bounds. So what I want to do now is I want to make it so that basically when you call end element, that puts everything together. So essentially like all of the stuff that we were doing here, so place rectangle, essentially all of this stuff is going to happen here. Like everything, right? So the default interaction thing is just going to go ahead and set the element interaction to interaction. The make element sizable is just going to set the size pointer to be the same as the dim pointer. And the element dim, I'm sorry, the begin element layout is just going to initialize these things to reasonable values, right? So the layout equals the layout. The dim equals the dim. The size is null, the interaction is null, the bounds are null. That's it. So once all those are set, then when we get down to the end here, we now need to figure out how big this thing is supposed to be, right? So the first thing that I would say we want to do is like, we want to create like the total dim of this thing. And the total dim is obviously going to be whatever dimension that they actually asked for. But now, like maybe, like we say, if you want to size the thing, right? You want to change the thing's size. Maybe we want to put like a sizing frame around it, right? Be a little bit more like a traditional thing where there's, you know, you can grab any corner of it or something like that and pull it out, or I don't know, right? It doesn't even make any sense to say that really, so I suppose I don't even know why I'm saying it, but let's just go ahead and pretend that you can do that. And so we're going to do that. All right, so we have one of these elements. We said that we were going to make it sizable. And so what I'd like to do is take the total dimension, and I just want to expand that dimension by however big I want sort of that size box's hit area. So if I take a look at the math, I think we might, I don't know if we have a grow or a Minkowski sum in here. Let's see if we do. Doesn't look like we do. I thought we did. There we go. Add radius to, right? So what I'd like to do is take the total dim, and the total dim, well, I guess I can just do it in a line here. It's just add radius to whatever that actual dim was. And this v2 is going to be like the frame. You know, it's like the chrome of this thing. And it'll start out at 0, 0. But if we have like a thing that we're trying to manipulate for the size, we'll take the frame and we'll make that be like, you know, size handle width or something like that. Frame y size handle pixels or something like that, right? And so we can just say, okay, there's, you know, size handle, it's 4 pixels wide or something like that. So we're going to add that like around sort of the outside of the thing, right? And then we now have the actual dimensions of the entire frame, which is, again, bigger than the dimensions of the thing that we're actually going to return to the user. We're going to tell the user that the thing is like the inset of that, the original dim. Okay, so then we're going to produce the min and max corner of the of the total and the min and max corner. Like, we're basically going to produce these rectangles, right? So I'm going to start by saying, like, okay, maybe we've got like total min corner and total max corner, and then we have yeah, and then we have the sort of the inset one as well. So we know that this is all actually correct, right? This is actually the corners of these things. But the part where we subtract the dim, instead of using just the interior dim, we want to use the total dim here. And then similarly for the max corner, we want to use the total dim for the width. I think we had about 20 minutes on the clock, so I'm going to go till about 6:15 or so, 6:20. All right, so we did that. Then we know that if we want to create the regular min corner and the regular max corner, like I guess client is usually what it's called, like in Windows, for example. I don't know, I'll call it the interior maybe. The interior min corner is going to be the total is going to be the total min corner offset by whatever that radius difference is, right? So if we add the frame to the total min corner, well, I guess we have to technically do, since it's kind of annoying because of the way that we've built things. No, I guess that's right. You just add the frame and you're done, right? So that's the total min corner. The interior max corner is just going to be the min corner plus the actual dim, right? Whatever that dim is. And the actual dim is just the element dim, like this. I feel like that's what we would need to do there. That seems right. I feel like this part, the total max corner, again, can just be the total min corner plus the total dim. That's just the definition of it, so we can just save ourselves some time there. And that all looks about right to me. So now we have both of these things. So we can produce anything that we want now. We can have the total bounds, and that's just the total min corner and the total max corner. We can also have the elements bounds that we're going to return to the user. We now know what that is as well, right? We have the interior min corner and the interior max corner, like that. And in here we can now use those to produce exactly what we want, our size stuff and our thing that we return, and we can do all of our size checking and everything else that we want to do. So in here, this is the code that does the advancement of the @y. And so I think what I'll probably do is push that all the way to the end. And the way that we'll do that, I guess the way that we'll do that is we'll say whatever the min corner is of the total bounds, we want to do that, and then we want to advance by the spacing, right? So I think that's just about correct. And then we need to sort of do that special case for the text there where we have somebody who's telling us what the spacing between two lines of text should be, which is different, than when we're putting rectangles together. So in here, when we do the rest of the stuff, excuse me, when we've got the size box that has to come in there, this is the code for putting that size box in place. For now, I guess what we'll do is we'll just draw sort of that total bounds as like maybe like a black border thing, and then we'll put a little thing in the corner of it. Well, no, but because we want to allow it to be see-through. So what I'll actually just go ahead and draw the whole border of the thing, right? So to draw the border of the thing, what we'd like to do is first I'll just draw the upper. I'm trying to think, can we even just, well, no. I'll just draw each individual part, because I think we're probably going to want to make this a little bit fancier in a second here. So drawing each individual part, we know we have to put a rectangle here, right? Something like this. And then we know that we need to pass whatever we want the color to be. For now, I'm just going to pass anything that's not the size box portion of it. I'm just going to pass black, just for now. Then the size box will have a separate thing. We'll treat the size box exactly the same way as we were doing before. So here's the size box code. The size P never actually gets used except in the size box there. So I'm just going to say we'll create the size box. We have the size interaction. We know everything that that's going to be. And we know exactly as well who it's going to modify because they passed that into us. So everything else here, I think, can just totally work, right? And I feel like end element, since it's doing the work, should probably also take the debug state so it can do modifications to it. Although I don't know, maybe everyone wants that. So maybe really that should just be something that gets put in here. Again, these are going to be on like sort of in the compiler's purview to like eliminate and simplify, I think, for the most case. So I'm not too worried about like sort of storing extra pointers and doing stuff here because they're just kind of temporary variables, and that's all they really do. All right, so there we go with the debug state. That all looks good to me. So in here, I can also pull that out, right? I could say that the debug state equals the element debug state, and I could say that the layout equals the element layout. And that's just like convenience. Okay. So I think that's all good. So I just have to finish this stuff up here. So the size box is the only thing that we don't have here. I'm going to make the size box be a rectangle min-max, actually. And the way that that's going to go is I'm going to have the rectangle min-max go from the get. I kind of want it to be, you know, that lower corner of the thing. So I want it to be the get min corner of the, well, this is that annoying thing that's, it's not quite the min, it's like the min-max corner. So I have to actually create the v2s to pick out the thing that I want, which is kind of annoying, but oh well. So we want the max corner of the interior, right, bounds. And I guess, you know what? I already have that. I know it's interior max corner. I want that x. And the y, I want the interior max corner y as well, right? No, sorry, min corner, because I want that lower one. And then I want the interior, the total max corner x for the width, and I mean for the place to go out to, and I want the interior min corner equivalent as well for the total. So I'm just kind of drawing from the interior to the exterior. So that's just that little corner piece. So that's the part that we'll do for the size box for now. And then for this guy, I just want to do, again, essentially that exact same thing. I'm going to sort of hand code here the rectangles that would give us a border around the thing. And then we'll kind of look at doing something maybe a little bit fancier in a second. So all right, I got to draw 4 edges. So I'll start by drawing the left edge, and I'll draw the left edge. I'm going to draw it without the corners in place for the moment, and there's a rhyme or reason for that, but we'll talk about it in a second. So I want to draw it without the corners. So what I want to do is the width, sort of the interior min corner, right, and the total min corner. Got those in the wrong order there. Total min corner, interior min corner. Sort of form the min and max that I'm drawing to xy's. And then the y is just going to be the minimum y, obviously, right, would be, you know what I just realized? These two are backwards too, aren't they? Right. This is going to be greater than this, always, right? So these are the minimums here, and these are the maximums. So anyway, I'm going to start at that total min corner. I'm going to go to the max corner in x, and then in y, I'm going to do essentially the same thing, right? I'm going to just pick out. I want to go from the interior min corners y up to the interior max corners y. So just spanning that entire interior length, right? And I can just do that exact same thing on the other side. So if I want to do the interior max corner to the total max corner, right? I can do sort of the, yeah, that was a big mistake as well. I can do the outside one, so that's the left edge and the right edge. And then I can do the top and the bottom here in exactly the same way, right? In fact, you could probably just copy exactly what I did here. So it's going to be interior, oh, well, but because we're going upside down, left and right, I don't know. It's a little bit flipped around, but either way. So for here, I want to be able to start probably at the total min corner Y and go up to the interior min corner Y. And for the X, I want to start from that interior min corner X, and I want to go all the way to the interior max corner X, right? So that's, again, exactly the same thing here. And that can be duplicated because this part is the same, and now it's just going to be these two guys are going to be slightly different, right? You're going to start at that interior max corner and go to the total max corner. So that'll draw all those rectangles. Let's take a look here. There's oops, mistake there. Debug state. Let's see what else we got. Add radius 2. Another two of those can convert all the element types. Add radius 2 rectangle 2 v2. Is that not what we had? We have a v2 and a, oh, right. That's actually just a dim. So we don't need to do add radius 2 at all. We can just add to the dimension 2 times the thing. That's pretty easy. So that's good. So there you go. Easier than I thought it was going to be. So then this guy, the size interaction needs to be part of this. Needs to be defined first. That's all fine. The mouse P we don't know. And so the mouse P also would have to be something that kind of comes in here. That's a little annoying. And we probably want to actually fix that in a slightly separate way. So we'll take a look at like that. Well, you know what? Actually, we can fix it right now. That would just go in here, right? That would be where that goes. Because that way, when you recreate the layout, you put the mouse P in there, and it flows through everything properly at that point. Okay. So let's see. This guy has to take the debug state now as well. Oh, and you know what? That's actually a good point too. Why isn't that in here, right? Because again, these are just, I think these will all be relatively easy for the compiler to compile out. Although, to be honest, without no aliasing turned on, maybe it will get a little confused, unfortunately. But yeah, this is not super performance-oriented code, so presumably we won't have to worry too much about it. We'll find out. So yeah, that is how we would have to get at the debug state. But I think that's better because then it doesn't have to get passed every time. It can just go like that, right? All right. So moving on. When we do the layout here, we would just say debug state equals debug state and mouse p equals mouse p, and then those are done. Okay, so what's going on here? We got our bounds, we're doing our push recs. That stuff is going to happen here. And it is going to happen with the element bounds. And let's see. Element bounds, apparently. What bounds are we talking about here? Okay, we're talking about element bounds again. There we go. We've got get width, identifier not found. I think it's actually get dim y. Oops, x. And layout is a dot there. Let's see, begin element rectangle. That's just going to take the address. All right, so we made a lot of changes, so I'm sure this will be a complete catastrophe, but let's find out. Wait, that's got a size box? Oh, we didn't put a predicate around that. Okay, my bad. Sorry about that, guys. You know, forgot about that. So yeah, after we construct all these things, this stuff, all of this, is actually only going to happen, right? All of that stuff is actually only going to happen if we had a size box. So let's just make sure that's out of there. That's not good. Why is that happening? What just happened there? If element size, you push all the recs. If not, you don't. We didn't make the element up. Well, that'd do it. We told it it was sizable. Operator error. Okay, good. So that's working. Now we just need to go in and actually add the default interaction, right? So if the default interaction was something, so like, you know, if this element's interaction, what did I call that? Interaction dot type. If they set it to something, then I want to do like an if, and I guess I could put and is in rectangle for the actual interior bounds, so the elements bounds, right? If that's the case, then I'm going to set the debug states next hot interaction to this guy. And I'd like this to, I'd like the size box to take precedence, even though now they don't overlap. If we chose to have them overlap, I would like that to take precedence. So let's see how we do. So somewhat surprisingly, everything seems to be actually working pretty well. So yeah, well, that went a lot better than I was expecting, to be fair. So yeah, we did it. Was expecting to have to debug some of that. Well, that's fine. I'm not going to complain about not having to debug. Okay, so now if we wanted to, right, we could also make it so all of these size pieces, like this was actually a thick frame that actually could have sizing associated with it or something like that, right, where you could go in and actually size from any of these pieces that you wanted to. I don't know that we want to really do that right now because we're kind of getting to the end of the stream. But point being, that's all now possible. And of course, we should also check, make sure that like these guys are also working properly. They are, right? So that's all good. Looking nice. Looking nice. So yeah, okay. I'm pretty happy with that. Pretty happy with that. So now we can also start to expand this thing a little bit more. So I think I'm going to save it for tomorrow because I think that's like where a good stopping point. We pulled out all of the layout code. So then now it's pretty trivial to just like, that's the entirety of the code that it takes to code a new element now, which is pretty great. And we can just start adding more things in there, like if they're movable or tearable or other things. We can make that sort of encapsulated in there so that you can just add more properties that you might want to your stuff. All right, I don't know if I can go to a Q&A because I don't have the ability to connect to the internet, apparently. It's pretty awesome. It's just, oh, poor Linux. It never actually ever works, unfortunately. I wish it did, because I would switch to it on everything if I could. But I can't, so I won't. So I guess I'll just go ahead and reboot this machine so I can actually use the wireless in it. And we'll just hope that maybe that works. Not particularly optimistic. Of course, since reboot doesn't work either, I have to actually Vulkan nerve pinch this machine and then start it back up again. But yeah, so I'll probably have fun reinstalling this guy tonight. I guess if I regress back down to 14, which is what it was running on previously, maybe that would work. I don't know. I would certainly be interested in suggestions from people who actually run Linux on Optimus laptops. People who run Linux on desktops, they don't quite understand just how hard it is to get Linux to run on an Optimus laptop. It's like almost impossible. Nothing ever works. The sound doesn't work. The graphics don't work. Sleep doesn't work. And of course, wireless doesn't work. And so if you are someone who has a lot of experience with getting Linux to work on Optimus laptops, modern Optimus laptops, do let me know if there's a particular distributions that you've found actually is reliable on them, because I would, I'll try installing some different things on it and see if any of them work. Since I have to reinstall it anyway, it's free for me to try out some different things. All right, so if you have questions, please post them with Q:, because I probably, and do it quickly, I guess, because I probably will only be able to see questions for like 15 seconds or something. But we'll do the best we can. It is kind of crazy how not working this laptop is. Yeah, this is a disaster. I can't see anything, can I? Why don't you connect to chat with your desktop? It's a good question. Because it was nice kind of having the chat up on the side that I could just look at, and it used to work. So I'm going to get it working again, and that way I can have it. So I'll do that tonight. I'll actually get it working to a certain extent, hopefully reasonable. I could also maybe just plug in a net cable or something like that. I don't understand. It's so weird. I don't understand how like it can't connect to the wireless anymore. Like, how does that even happen? How does it even happen? I don't even know. So it just disconnected again. How is it? Like, how are you connected to the wireless and then it just stops working? It doesn't make any sense. Like, what is happening inside? I wish I could see the code right now. I mean, the Linux code is public, right? So like, I want something where I can just kind of, they need some like a Linux code explorer when I can just go see like, okay, show me who is actually responsible for the wireless networking right now. What is the code doing such that it could connect and then just spontaneously disconnect even though nothing has happened? You know, nothing at all. And I wish I could understand this, but I don't. It's a mystery to me. And there's like tons of different wireless networks listed here, and mine's listed, but it just doesn't think it can connect. So fascinating. Is this like what, I don't know either, like is this what it's like? Like when Linux developers are like using Linux, is this what it's like for them? Did they have some kind of magical machines that work? Or are they just like cool with it? Are they just like, yeah, you know, it doesn't work, it doesn't work. Like, I just won't use Wi-Fi today, or until this kernel gets revised or whatever. Yeah, so I think that's not going to happen. All right, so I guess there's no QA today. My job for this evening will be to restore the laptop to working order so that I can actually answer some questions on the stream. You will have to wish me some luck with that, because it's Linux and luck is usually very much required. So hopefully, if I am lucky, I will be able to find a distribution that will work on this laptop without me having to go like patch the drivers or something. But you never know. Okay, so I will wind it down. Hopefully the stuff that we did in today's stream was pretty straightforward so that there wouldn't be too many questions about it. Essentially what it was, you know, was sort of the same thing I did in the witness. Right, and so, you know, if you want to take a look at this some more, you can go, if you type caseymuratori.com in, it'll just redirect you to my page. Easy to remember. If you look at the Working on the Witness series here, they're not very, I'm going to move this over to the new WebGen stuff because it's better. But like you can jump through these. The first, like, I think up through 11 maybe are grass. But then number 11 starts talking about almost exactly the same thing. So the witness code looked exactly like our code from before this stream kind of looked. And this is like the sort of stuff that was happening in that code. And again, it was just because nobody bothered, like really cared about that part. And you know, John's pretty good about like not over-engineering stuff. So it's like if people haven't done a lot of UI, then there's just not, it's just like whatever, it's whatever it is. But it's still usually written pretty sensibly because John's a good programmer. And so, you know, that's what we had at the beginning of the stream today. Like when I came across it in the witness, it looked exactly like what we had in the stream today, sort of. Everything was done manually all the time, for the most part. And very few things had been compressed out. And so what I did is I just went through and did exactly, like you can see, I even made the same thing, like a panel layout guy who starts doing the layout. And I just kind of started reducing the code down. And like I said, I think that's sort of the same thing. That's like John's approach too. So it's like, again, I don't think it was like John wanted the code the other way. I think John just never cared about this particular piece of code. And so he was just kind of waiting for time to actually do any of that stuff, I assume. And I was the person who happened to be writing a lot of UI code. So I was like, now is the time. And so literally, it's, you know, what I showed in today's stream is literally something I did on a production project, like not less than 2 years ago, right? Because on any project, especially one that's as big as the witness, nobody has the time to go do the right thing everywhere, right? Like forget it. There's too much stuff to do and too much to worry about. And so you have to pick and choose where you're going to do stuff. And so the right time for something like what I did is when somebody's going to come along and do a bunch of heavy work on this thing, then that is the time to go, hey, let me get more serious about this, right? And so, like I said, this is exactly the sort of thing that happens. And like, so I literally, this is the kind of thing that I actually do in real life. It's exactly the same. And you can almost see it playing out exactly the same way. So if you look at these articles, the stuff I did on the witness for like just cleaning up the UI system a little bit for the editor is exactly the same stuff that we did today. It's just really standard, very straightforward coding. And it's, like I said, it's a really good way to go. Lazy compression is a really good programming methodology because it means you're not spending a lot of time over-engineering things that don't need that, but it does mean that like you're not going to end up with total spaghetti code because you're actually doing the compressions when necessary. And you know, it's generally the case too. Like on the witness right now, the places that are spaghetti-ish are just the places where people haven't had the time to go, you know, actually figure out how to like pull the stuff out of it and make it like cleaner, right? So every so often somebody, when they're like, oh my God, I'm going to go have to do a bunch of work in this code, I know it's kind of messy, that's the time to go, okay, hold on, stop. Before I do that, let me go pull some of this stuff out a little bit more before I start making it worse by adding, you know, more UI code on top of a kind of a super verbose, stringy implementation. Let me stop. Now is the time to like figure out some compressions on this, get it down to a nice, simple core, and then I add on, right? Don't be the guy who just comes and is going to add 100 UI features and just cut and paste all the code and adds it all, and it's just, you know, don't be that guy. When you come to something in like you can see that the programmer before you hadn't yet put it into like a toolkit kind of a thing there. Like, go do that work first. Don't leave a giant mess for them, you know, it's kind of a good thing. So anyway, you can take a look at these. There's a bunch of posts on it. There's quite a few actually, right? 14, 15, 16, yeah, 17. So that's that. All right, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along at home, you can pre-order the source code on handmadehero.org. Well, pre-order the game. It comes with the source code on handmadehero.org. You can download it every night. I upload it right after I'm done, so you can always work on sort of the most recent one, just like I am. We also have a Patreon page. If you want to support the video series, you can subscribe to that. It's always much appreciated. We also have a forum site where you can go to ask questions or view an annotated episode guide with previous episodes if you missed any and want to catch up. We have a tweet bot you can go to if you want to know what the schedule is. Yeah, if you want to know what the schedule is for tomorrow, I will be back here 5 p.m. Pacific Daylight Time tomorrow, and we will do some more UI coding. It's starting to look pretty good. Like I said, we're getting there. We're sort of starting to get things into a pretty nice, clean way. And so we can start to sort of tighten a few more screws down on that and then add a few more things to kind of let us, the thing that I really want to do is be able to view like our profile and view our memory. We need some UI for that that'll work a little bit better than what we've got now. So there we go. Hope to see you back here tomorrow. Until then, please have fun programming, and I'll see you guys on the internet. Take it easy, everyone.